I'm assuming that's what everyone's here for, is learning Python. So this talk is Python 101, and we're going to be covering the basics of why you should be using Python, why Python's a great language to use, what makes it powerful, and how it can apply to several different applications. Not only like web applications, but also like personal projects if you need to write a script, to just parse through a file, to show you information off a website or anything at all really. Python's pretty powerful. It's also it's a higher level language like Ruby and like C++ and Java. So it takes your code and it interprets it. It's an interpretive language. So if you've ever used a Linux computer or Mac computer, when you're using a terminal, you're using Bash, which is also interpretive language as well. So when you type something in, your code's being executed immediately. You're not having to wait for it to save to a file, then throw it through a compiler, and then wait for the execute code to show some output or handle your data. So as soon as you type in code, it's valid. Or not valid, but it processes it immediately. One of the advantages of Python code that I'll be going over and I'll be showing as well is Python, and this is why I believe Python is a great language. It's very easy to read. It's very English-like. A lot of the syntax was designed to make the code very readable by other people. So if you're working on a project and you want someone else to come up to it, they can take a look at it and they should be able to very easily understand what it is, because a lot of it will almost form English-like sentences. A lot of your comparisons can be done in using English operators instead of using weird symbol operators. Like if you're familiar with Perl, you have an array of goofy characters. Okay, sorry about that. I did not know I had timeout. Sorry, I must apologize. This isn't not my laptop. It's the third laptop we had to go through to get a display on the projector. So I'm not entirely too familiar with this system, but as far as Python goes, Python's pretty much the same everywhere as long as you're using the same version, which that's another thing I should bring up real quickly, is that I'm using Python 2.6.6. On most Linux distributions, when you install Python, or when you install a distribution that comes with some type of Python, most of your distributions nowadays have some dependencies on Python. For example, if you run Fedora, Yum depends on Python. Actually, Yum was entirely written on Python. So if you're in Python, you can actually import Yum and call methods off of it, and you can actually essentially add new features to it, or even fork a project and make your own package manager from it, which is pretty nifty. I actually wrote a script once that handled output from Yum, and it was very easy to do because Yum's Python. You could just simply import Yum if you're on a Fedora system. Another advantage of Python has a huge standard library, very powerful. You can, if there's something you'd like to do, there's most likely a standard library for it, or someone's created a project that they've put on GitHub, Google Code somewhere, Gitorous, and you can just download it, and you can treat it as a library essentially. So there's a vast majority of things you can use. In fact, there's a Google Voice one where you can actually send text messages using Google Voice. You just need to store in, you're using a password. Well, it actually prompts for your password, but someone wrote the library. It's on Google Code. I think Google wrote it. I forget who officially authored it, but it's one nifty thing about Python is you just import Google Voice once you download it, and essentially just write text messages, check your voicemail, and you can essentially create like your own server to ping and check for information, do a backup of your text messages. So Python's really powerful in that respect. A few things about the actual syntax. Python is dynamic and strong, which means that the dynamic means that you can't, the type checking isn't done until you actually run your code. Other languages like C++, the type checking is done when you run it through a compiler. And what I mean by types is you have like an integer, a boolean, strings, different types of variables. And then strong just means that you can't mix different types. So you can't add an integer to a string. You can't subtract a string from a list or an array, essentially. So you can't do this. So that's just a quick classification about Python. And then some common programming paradigms that are used in Python is what's called the ZenPython. And if you run a Python interpreter, if you just do import this, it'll show a list of everything that I believe it was Tim Peters. I believe was his name. It should be listed up here. Let's see here. All right. Well, I'm not going to try to fiddle with that. It essentially describes about like what's preferred in Python, around the philosophy of and what you should be doing with Python. One big thing, and it's kind of a disadvantage to some people who are coming from the Perl world, is that Python is that there's preferably only one way to do something, and it's usually obvious how to do it. Whereas in Python or Perl, it's Tim Toady, where there's more than one way to do it, and you can write one line of code in probably about an infinite number of ways, and they allow that powerfulness behind Perl. In Python, we try to make it very, very fluid, try to make it more intuitive, more English-like, and more easy to adapt to different situations. So you can essentially write a code and pass off libraries essentially, and people could take that and use it. Since this is a tutorial talk, one of the tutorials I'm working on, I'm going to state the project name, so if anyone who wants to follow along could go ahead and start working on it. And I already have the code written up, and I'll show you the code I came up with it. But the idea is, is anyone here familiar with the birthday problem? Or the birthday paradox? I don't know if it's a paradox, but it's a statistic, I don't know if it's right here, but it's a statistical analysis that says that if you take a room full of X number of people, after you hit a certain number of people, you can define what the chance of two people sharing the same birthday. And I believe at 23 people, you have a 50-50 odds of two people in the room sharing the same birthday.
And let me interrupt just one quick second. Extension cords and power strips, in case if anyone needs them for their laptops, so they can continue to work. I'll just set them back here. You can just put them wherever. Sorry about that.
Oh, no worries. All right. But the birthday problem, 23 people in a room, should be a 50-50% odds that two people share the same birthday. The idea of the tutorial is that you build a script that simulates different rooms of people. You define how much people are in each room and how many rooms you want to test. And then you calculate out what the statistic should be and what the statistic actually is from random generated data, essentially. And you generate your own people and the birthdays. It's pretty nifty. If you love statistics, you might find it very interesting, but that's kind of the goal of the tutorial, is to walk through that and to create that. More so, it's going to be about learning a language, and then I'll deviate a little bit and pull up the actual file I've written and show you the things I've explained and how it relates to how it's usable in the script itself. First, oops. All right. All right. First thing about the syntax or about the actual language itself is the different data types. I briefly touched on this. In Python, you have a few basic data types. You have what's called a list, you have a string, you have a dictionary, and you have an int, and you have a float, you have a boolean, and you can actually find out the type of any variable or any information you have by just using the global function type. So if I create a string, let's say hello world, and then I want to know what the type is, I can just do type A, and it tells me it's a string, str, essentially. So that's an example of how, if you have an object and you have no idea what type it is, and you want to know how to interface with it, you always do type. Another thing you do on an object, if you're not sure what it does, you can also do a global function called dir, and it will show you all available methods you can call out that class. Most people here, I'm hoping, are at least have heard of object-oriented programming. For people who aren't familiar with that, the idea is everything in the language is an object, essentially, and you can call methods off of it. You can you essentially call methods off of it. You can do different inheritance. You can build on different objects, and it makes it a lot easier because with object-orientedness, you can abstract your code and make it a lot more portable. So that way you're not having to essentially reinvent the wheel in several different spots. And that's why classes are so important, because you can actually create your own objects for that represent complex data or complex systems, essentially. So like if you want to make a representation of a car, you can create class car to represent a car. But that's about your different data types. Like I said, you have lists, strings, ends, booleans, and what you can do with those, you can create those. So like in most languages, you can do, let's say, my list, and well, actually, the output of dir is a list itself. And actually, I should back up real quick. I'm using what's called IPython, which is the interpreter. On most machines, you could just run Python, and you'll get an interpreter. And you can just type in your code and go about test in Python. I'm using IPython mostly because it makes it easier to do tab completion for methods off of classes. The standard Python thing is available on most distributions. If not installed already, you can find through the repositories. IPython, you most likely have to get through the repositories. So for aptitude, it's just IPython. I believe for Fedora, it's the same thing. But it's a lot more helpful for tab completion if you're in an unfamiliar environment and you want to tab complete methods off of classes and objects. Which makes it a lot easier and faster to code, in my opinion, for when testing stuff out. So let's pull that back up. Yeah, kind of see down here. Okay, so as I was talking about assigned variables, a string is just your hello world, and then you do my list, and then a list, like I said, it was just, you have your square bracket, you have A, B, and C, and you create a list. There's only supposed to be one square bracket. All right, let's run it kind of slow here. All right, nope. Yeah. Backspace on a Mac doesn't actually, backspace does. Okay, there we go, yeah. Command backspace, okay. You can tell how often I use a Mac. All right, so you create a list. It's essentially, a list is, in Python is essentially an array in most other languages, so it's an ordered group of elements, essentially. So you have your first item A, which is 0, your 0th identifier B, which is your first one, C, and this example is your second one. So if I did my list 0, I'll pull out A. And if I did my list 2, I'd get C. And you can also do -1 to get the last element, and you can also do -2 to get the second last element. And the reason I bring up lists first is, or arrays essentially, is because there's kind of like this sneaky little thing or convention that kind of slightly carried over from C, so C++, is that if you've ever done C work, you don't technically have strings. You just have to keep making arrays of characters and make sure you put your null terminator at the end. So with that kind of somewhat carries over to Python because strings are treated like lists or arrays in Python, which can be very useful, especially when you get into splicing, which, what I mean by splicing is, if you've ever had to like pull out a substring from a certain position to a second position, and I believe it's in PHP, you have to define the number with one function call, and then you have to like pass like the first variable, and then what you want to replace, that's a replacement, but you have to provide all the numbers, and you have to pass out 3 variables for it. Whereas Python, you can actually do the substring matching within within the accessor. I don't know why the word accessor almost slipped my mind. So for, where is it? My list. So the variable A equals hello world. So if I just wanted to, let's say, print, let's say index, what is it? That'd be 0, 1, 2, 3, 4, 5, 6 to the end. I could do A6, and it would just show world. So essentially what this is doing is you get your 6, that's the 0-based index where you're starting at, and then the colon just means go to the end. So essentially what this is reading, it's reading as, so it's reading it as 6 colon and another number, but it's using the length of the string as a hidden number. And then you can change the second number essentially. So the first number before the colon is where you're starting at, and then the second number is where you're ending at, and what you want to display out of the string. And the reason this is important is because in Python, strings and lists kind of go hand in hand. But the difference is strings are immutable, which means you cannot change different indexes inside the string, but you can with a list. So what I mean by that is, if I go back to the example of my list, so I have ABC, I can do something like this where I want to change the first element and I want to say foo. So if I print out my list, I get A through C. So with this example, I can change different elements in a list. A list is not static. It's not a constant. I can dynamically change that. Whereas with a string, on the other hand, if I did A, and I want to change that to, let's say, a capital B, you can't do that. And it'll tell you, string object does not support item assignment. But the fancy word for this is it's immutable, which means that you can't change those objects. And the same thing with a set, too. A set is a static list. And the different syntax for that is you use parentheses instead of your square brackets. So if you did like my list 2, you do A and Z. And then to demonstrate that that's immutable, if I did, can't do it, well, technically it's a tuple, but I call this, some people, when you look at the documentation, when you look at Python documentation, they call it a tuple, but if you look at some blogs, they'll call it a set. People interchange the word, so it's technically a tuple in the Python world. So tuple object does not support item assignment, same errors we saw before. In simpler terms, it's immutable, so you can't change those values in there. So you can keep, sets are essentially the same thing as a list, they're just static. So they're very useful. So when you want to use a set, like if you're iterating over something, there's a chance you might accidentally overwrite something in your code, you might want to use a set. Or if you're pulling in information from a URL, for example, that would be important as well. And then for list arrays. So arrays, you can also treat them like a stack, essentially. So you can do like a .pop, and you can do a .append, and there's several other methods listed on it, so you can do similar operations. So if we go back to my list example, we have A through C, and then you could do pop, and then we can say, well, what's at the end of it, and now end is C, but the pop, it will actually move that from my list. So now my list no longer has that last element, essentially. Now if I want to put it back, you can do append, which some other languages, they'll use push instead, which just puts it back at the end of the array. So you can do my list append, C, so, and the append changes the list in place because it's a method off of that list, essentially. And then same thing with pop, it's a method off of it. So this is going back to your object orientatedness. The .pop is a method call off of the class that represents my list, or off that object. I shouldn't really use the word class because it's an instantiated class technically. So yeah, that's your lists. And then strings, like I said, it was just A equals, or your variable name equals, and then your quotes. Another thing, and this is kind of like a little different than like C++. So if I did, you can also use single quotes, and that will still work. It's not specific. You can also do you do triple single quotes, or you can do triple double quotes as well. And the nifty thing about that is if you're doing this inside a file, Python technically does not have multi-line comments like other languages do. Where in C++ you have the /*. In Python, you would just use 3 single quotes, your first line, second line, third line, and then just end whenever you're done with the matching 3 quotes there. So kind of an advantage of doing that is it's technically, if you're doing a multi-line comment that way, it's technically it's a non-assigned string. So you're creating a string, you're just not assigned to a variable, and that's technically valid in Python because it's still legal code. You don't have to make a data set and assign it to anything really. You could just throw it in there, but you're not going to be able to access it later, essentially, because you don't know what to call it by, because it technically no longer exists, or well, it exists, but you can't access it, essentially. Okay. Make sure the screen doesn't go out on me. And also with strings as well, strings the difference between strings and lists, besides being immutable, is that with Python, a lot of times in other languages you might have to write a function to, let's say, like split or well, not really split. Most languages have a split or a dot find or replace, but in Python, so with where's A equals hello world, if I want to replace the word world with someone's name, you could do world, and I could say, oops, Mike. But it doesn't change it in place. You'd have to assign that back to a new variable. So if you want to overwrite, you do a replace, right? And then now it would change, and you essentially replace the world with Mike. There's split as well, and splits. What's really powerful about split is it assumes a lot initially when you don't call with parameters. So if I did a.split, oops, I need to close my parenthesis there. It splits on all white space characters. So if you have tabs, spaces, any other white space characters, it would split on those. So you can intermix those essentially, and it would just throw those all out and split on every occurrence it sees one. And you would end up with, and well, at least in this example, since I only had one space, I end up with hello Mike. With the dot split, you can specify what you want to split on, and you just provide it. So if I want to split on exclamation points, for example, it would return everything up to that, and then what's after it. And since there's technically nothing after it, it ends with the second element. And the return result here is a list as well. And then you can loop over that, which that's what I'm getting into next is. And this is what I find, in my opinion, I think is really powerful about Python is its for loops compared to other languages, where you can loop easily over arrays, or I should say lists. You can loop over lists very easily. So, for example, where is it? Import info.county. So I have this file called info, and what it is it's info.counties, it's a list I have set up in another file. And the way I did import info is I have a file called info.py. And you can import the other Python files. And any type of data you have in there. So I just have a variable. Well, actually, I'll just open it up to show you what's in there. So I have a file in there. And I should probably mention the shebang line at the top is is technically a comment. And it's telling, when you run it as an executable, it tells you where to find the Python interpreter. This is a bit general. It's just saying whatever your environment variable is for Python, just use that. A lot of your more legacy code that needs like an older version of Python, you'll see like /user/bin/python like 2.4, or specify like a different path for Python. But this is just generally using if you use the /user/bin env, it's going to use whatever path when you do which Python in your terminal. So that's just a general way to do it. And then I'm not using those to import things. Those were just kind of left over. But the counties is a list, and it's listing all the counties in Ohio in alphabetical order. So you can scroll through here. And I also have states, which is a dictionary, which I'll get into that here in a little bit, but I'm going over the lists first. And then this is just, a dictionary is essentially a mapping or like a hash table if you've done Perl before, where you map a key to a value, essentially, and all the keys have to be unique. And going back to the immutableness of strings and sets, your key has to be an immutable data type. You can't use a list as a key. You can't use another dictionary as a key. Your keys have to be immutable, which means that they can't dynamically change in your code. So that way you can make sure your keys can't change, essentially. So it prevents your keys changing outside of the dictionary when you're not doing a dictionary call. That's why your keys have to be immutable. But your values can be anything, any data types. You can have a dictionary of dictionaries, you can have a dictionary of lists. Your values can be any data type. And then this is just a syntax here where you list, this isn't dimming up here every few minutes, is it? On the projector? Okay, all right. It's dimming down here. It's giving me the perception that it's dimming up here. So, you know, you got Michigan mapped to MI, you have Ohio mapped to OH, North Carolina NC. And I'll get more into dictionaries here in a minute, but I was just explaining like how you can import other files. If I could get out of it. All right. I think I'll leave it alone for now. I've already spent enough time filling with laptops today. So, but back to IPython. So if I do import info, I could do import.counties, and I could call that variable name from that file, and I can access information. And if I had functions in there, I could do the same thing as well. But we'll get into that here in a minute because I'm kind of trying to a bunch of teasers here. I have to talk about what a function is first before I can start saying who you can call them. But what I was trying to go with this initially was for loops. And for loops over lists are very powerful. So in Python, very simple to do. You can do for each in info.counties, since that's the variable name for the list. And you can just do print each. And it prints each item in the list, essentially. And it doesn't show the syntax, because with IPython, it shows every item in the list on a new line. If you're using the standard Python interpreter, it's going to just clump it all together, and it's harder to read through. So, and you can expand on this. You don't have to use the word for each. You could do for x in info.counties. You could do like x, and let's say if I only want to show the first character of each element x, I could do print x 0. So what this will do is it'll just loop through, and it just showed the first character of each item in the list, and that's why you get a bunch of just alphabet, a list of characters. Not that useful, but yeah. And speaking about usefulness, going back to the tutorial, let me pull up the birthday problem real quick to see if. All right, well, I have to go over that first. So, one of the most common, one of the things you usually do when you're writing Python or any interpreter code is you want to ask for some input occasionally, or you just want to pass command line arguments. And Python, to take input from the terminal, you would use raw input. Let's say, please enter a number, type, and through in. And then you would type in whatever, and it would print, and the interpreter is just going to print back out what you type. You would have to assign it to a variable to make it useful. So you would do, do a equals raw input, enter a number, and say 34, and then a 34. Now the cool thing you do with this is if you drop off the raw underscore and just use input, people can input Python code and it'll actually evaluate that Python code. It can be dangerous, so don't really rely on that, but if you want to kind of make your own interpreter just for your own use to play around with, you can just make an infinite while loop that just keeps asking for input essentially, and it will just ask for it. So if you did, let's say b equals input, please enter statement, or not statement, just please enter data. All right, so we enter data, we'll say 2 to the power of 2, print b, you get 4. So it actually evaluates the 2 to the power of 2. And then what's evaluated from that is stored into B. So not really safe to do if you're trying to do some secure coding, but can be useful depending on what you're really doing, if you're trying to learn a language or if you just want to make your own interpreter to play around with. Pretty nifty. And you can, yeah, so and what goes into parentheses is what your prompt is essentially, and it doesn't add a space at the end automatically. So that's why I'm adding the space, colon, space at the end there. So input and raw input are two ways to gather information from the terminal. The for loops, like I said, you do for the name of your temporary variable in an item or in your list. And then your while loops, or like many other languages, you'd have to assign an integer beforehand. And I should have mentioned this as well. You don't have to, your variables are when you declare them or you create them, you don't have to initialize them essentially. So like if you've done C++ before, you'd have to define, okay, I got this type, I got this variable name. And you have to do all that listing before you actually use the variable names. In Python, you don't do that. They're all dynamically generated essentially. So when I do like I equals 0, it's essentially just taking 0 thrown into I. Or I could do an expression and if I doesn't exist, it will create I and then store it in there. So, and this is one thing I forgot to mention. You can create a list of numbers very easily. So if you want to create like the numbers 0 through 99, you do range. It's just range, the number you want to start at, and the number you want to end at. And the number you end at is non-inclusive. The number you begin with is inclusive. So it's kind of slightly different, but it's very useful if you want to quickly just generate a bunch of numbers and want to mess around with them. So where was I? So I. So if we take a variable and start off at 0, you can do while I is less than, let's say, 10. Oops, if I can spell while. All right, so you do while I is less than 10, I plus equal 1, like it. All right, and that's the other thing about Python is to increment an integer by 1, it's plus equals. You can also do, and this is equivalent to I equals I plus 1. In C++, you can do I plus plus, semicolon, but Python doesn't have that nice little feature. But the nice thing about this is, though, you can increment by 2s, 3s, etc., or anything as well, and you can still keep this notation. You can do I plus equals 3, and it would increment by 3 every iteration. So we can do like print I times, we'll do I times 2. And then you get, every number times 2 through here. And to relate this back to the problem I provided at the beginning of the class for those who want to build something on a lap with me right now, the birthday problem, the raw input is what you would probably use to let the user pick your information, like how many are in the classroom and how many times you want to simulate it, essentially. And your mathematical operations, your multiplication is your asterisk, your division is your slash, and it does, when it does integer division, it rounds down. But if you want to get a float, you have to have one of the objects be a float. And Python, when I said Python doesn't mix types, what's technically doing here, even though the one's an integer and one's a float, it's actually forcing the 3 to a float. So all you have to do is have one of them be a float, and it kind of knows to treat the rest of them as floats, essentially. So it's technically 3.0. And the reason you get the 8.33339 is because it's the precision with, yeah?
So you could have 25 slash 3.0, and it would still give you the 8.3.
Correct, yeah. Yeah. And yeah, the long list of 3s that deals with precision of the processor, there's a Python library called, I believe, decimal. You can import decimal, and it will handle division and multiplication, and it will account for this precision, essentially. And the example I referred to, the birthday problem, I used that module because when you start dealing with large numbers, the precision can start really affecting your math at some point. So that's good to know. And then subtraction, 6 minus 3. So it's mostly like, a calculator. If you need to do some quick math at a terminal, just open up Python and you can just type in your math. And to the power, 7 to the power 2. And this kind of deviate a little bit. There's import math. And this has a whole world of other math functions. So if you want to call cosine, you want to call like the pi, or you can do like math.pi, oops. It will pull out a constant that has already signed for pi, essentially, so that way you're not having to define that variable every time you open up your code. I believe there's math.e as well. All your trig functions, including their inverses, I believe, are available as well. And there's also import cmath, which is your complex math, which I believe includes all your trig functions, but with imaginary numbers. So you can also handle that as well, and it's really powerful. So that way you're not having to treat it as a string, or you're not having to use different data types to represent the imaginary numbers. And in fact, the imaginary numbers, I believe, it treats as the A plus BI, I believe is the format for them. So it'll just, print off as that when you evaluate it. Deviate a little bit here. Where was I? Oh yeah, the while loop. So I showed the while loop. Yeah, I already showed the while loop up there. So the while loop, the review again, if you want to create a infinite while loop, you just do while one, and you can do like print A. Oops. And it'll just infinitely print until you Control C it, which Command C. Yeah. Okay, there we go. Actually, I killed IPython in the process. So I don't think the Control C was passing from the Mac. As you can tell, I'm not really familiar with Macs. I'm not ragging on them. I'm not familiar with them. So back to IPython. So we're doing the lists, or no, we were doing while loops. So the while one print infinite loop, you can do while true as well. And for your booleans as well, I kind of hit at this. And if you've done other programs before, technically a boolean is a subset of an integer. It's inherited from an integer. It's essentially either a 1 or a 0. So your true is a 1 and your false is a 0. But in Python, you could just use the keyword name true, or you could just use the keyword name false. Or actually, it's capital true, capital false. In C++, it's lowercase f, lowercase t. So that's quick boolean. And if you did a type, you'll get if you get type, you'll get bool, essentially. Well, you do get bool, so it tells you what the type is. So that's your while loop. Your while loop's pretty powerful. You'd have to declare some type of incrementer beforehand, and then you increment inside the while loop and have some comparison. And speaking about comparisons, your comparisons are very similar to other languages if you've used other languages before. If not, the way it works is it's like if you've done math comparisons before, like 3 less than 5, 7 less than 12, or 15 greater than 8. You could do 8 less than 13, and it will evaluate that statement on the interpreter, and it'll tell you it's true. Or if you did 8 is greater than 13, it'll tell you false, because that evaluates false. And you can also throw in your equal signs. Your equal signs have to go after the greater than or less than symbol, so it has to be the second part in that operation. So 8 greater than or equal to 13, since that's not true, it evaluates to false. So your comparisons, what's nifty about your comparisons, you can also do, and this kind of ties in with if statements, which I'm trying to bring up with this as well, is you can do like, so back to the counties thing. Info counties. Oops. So, oops. All right. So what appears to happen is when I did the Control D thing, it jumped me out of the window and tmux to a different one. My directory changed. So we'll import info again, get info. And the thing about the comparisons is we could do if Franklin in info.counties. There. Oh yeah, print yes. And it prints yes. So what's really nice about this is you can give it an arbitrary temporary string that's not assigned to a variable and say in, and it checks to see if it's in whatever variable you're calling. So you're checking if the county in Franklin, which is where Columbus is is in the list of counties I have available. And you can also do this for dictionaries as well, which is very useful. So that way you're not having to loop through the entire data set to find out if your object is in there somewhere. So you do if Franklin and info counties and print yes. So you can also do if Franklin not in. So you can do Franklin not in the counties. And we won't get any output with this because Franklin is in info.counties, so that if statement evaluates to false and therefore doesn't do the if or the print yes. So it's your basic if statement. An if else statement, you would just do you would have if Franklin in and then your else would just be else colon, and then you'd run it like that. So your else would just be your catch-all, essentially, if you've ever done if statements before. So if that doesn't evaluate to true, just run whatever's in the else part. And you can also do if else as well, or not if else, else if. And that way you can specify different cases as well. So you could do if Franklin, info.counties, print yes, else if Cuyahoga and info.counties. And then you can basically break down like essentially like a case statement like you would see like in C++ essentially and go through that. So that's your basic if statement, basic kind of touch on comparisons. The in is pretty powerful, like I said, so it's easy to see what's inside other variables or do comparisons to see if something is in the variable. So that, your if statements in Python, and this is what I was going back to, it's very English readable, is like instead of, it uses a word in, which makes it a little easier for someone who's either new to Python or is coming up to your code, can look and understand, well, so it looks like they're trying to take this object and see if it's in this other object. And you don't have to use the word is because it's implied there as well. So it's just if blank in blank, execute the next line or the next block in line. And that's one thing I kind of forgot to mention. It's very important, is the white space is how you define your scopes in Python. So you can have multiple lines for the if inside the if spot. So if we, well, actually it'd be easier. Did Franklin and info counties, we could do print yes. And we could do print like 7 times 2. All right, so whatever is indented below the if statement is all part of that scope and can be used in that scope. Same thing for the else statement as well. So all your and if you're not familiar with what a scope is essentially all block is like think of it like directories. If you're on Windows or Linux, what's available across the directories if you recursively go in. So if the further indented you are, what's available there, what you declare there stays there, and what you declare further up in the tree or further up is accessible deeper in, essentially. Folder ID was probably not a good analogy. So you can nest if statements as well. So you can do if Franklin and info.counties, and then the next line you can do if 7 is an integer. You can just keep nesting those, and you just keep indenting. So like your third line would be more indentation, and it's kind of hard to do long multi-line statements in an interpreter, whether you're using IPython or whether you're using Python interpreter on a command line. So I'll pull up the birthday problem and go through that and show the multiple indentations for that, because it's a lot simpler to do that. And that will give me an opportunity to show you the part about dictionaries as well for listing those. Speaking about dictionaries, yes, dictionaries. So dictionary is, like I was saying before, it's like your hash map or your hash table. It's a mapping. You're taking, you're mapping elements to other elements essentially. And we had if info.states is a dictionary create where we map the state names to the 2-digit codes. So we, Texas to TX, Ohio to OH. And the syntax for this is you put your first key or your keys, colons, and then your value, and then comma, and you can have multiple entries within your dictionary. Which is, like I said, if you've used Perl before, it's like a hash table. If you haven't used anything before, think of a hash table or a mapping like a phone book, essentially. You open up a phone book, you look up someone's name, and it's mapped to a specific phone number. So, and actually it'd be inverse. It'd be a reverse phone book lookup. You can look up, you'd have, your keys would be your phone numbers because they all have to be unique. And then the names could be your values because multiple people can have the same names and have different phone numbers. Essentially, if you ever open a phone book, you'll see like there's like 100 John Smiths within a large city like Columbus, or at least, I don't know if there's 100, but you'll see repeats of names. So it would actually be a better analogy to think of your keys as a phone number and then your values as the name. And you can also do, like I was saying earlier, you can have different data types as your values, so you can throw in a list as well. So you can have, we'll say, who equals dictionary, and then we can say Mike's mapped to a list of, we'll say, birth year, birth month, and birthday. So you could do that, foo, and then you just have a list as well. So Mike, the string Mike is mapped to that list, essentially. So if I want to reference Mike, I can just do Mike, and it pulls out the value for that. And this is the accessor for a dictionary as well. It's just square brackets, and then the variable or that's inside your dictionary. So if we did info.states, we can do Virginia, and we get VA. Now, let's say for our dictionary up there where we had the list of states, let's say if we want to do a reverse lookup, we want to take the 2-digit code, TX, and we want to get Texas from it, instead of going Texas to TX. You can still do that, but that would require you to do a loop for it, because you can't, or in this example, we're sure that there's 50 unique states, there's no duplicates. I could populate this table, or not table, dictionary, so that we have we have different states with the same value, essentially. So I could make an erroneous entry and say Washington, it's actually WV. It's not true, but that's still valid, because dictionary, because as long as the keys are unique, the values can be whatever. So you can't guarantee that you can do a reverse mapping, essentially, because there could be multiple keys with the same value. So it's not very, if you need to do that kind of reverse lookup, you'd probably want to store it in a different data set, most likely like a true database at that point, depend on how you want to parse the information. And speaking about databases real quickly, Python comes with SQLite 3 for people who are real into SQL. So you don't have to install like MySQL and configure or run in the server or anything like that. And SQLite 3 is just it's technically a flat file, and you don't really need to set up username and passwords. It just stores into a .db file, and it's a lot more portable than like trying to move a MySQL database file, because you don't have to shut down services or anything like that. But it comes with Python, and it's very usable if you need to just quickly store stuff in a database. If you need more efficient database usage, you'd probably want to use MySQL or Postgres, or whatever other database types are out there. I don't know if there's a MS SQL available for Python, but it wouldn't surprise me if there is. I spoke too long there. Okay, good. All right. I'm starting to like Max a lot more. Okay, so the dictionaries, we could do reverse lookups, but we'd have to loop over essentially. So we could do, and looping over dictionaries is kind of unique, but I should back up here. So we could do info.states, and if, like I was saying earlier, you could do a dir, and what dir does is it shows you all the methods off of your object. So if you don't know what's available for a dictionary, you can find out yourself. So you could use info.states, and it shows you what's available. So now you can see you can do .clear, .copy, and if you're still not sure what these are, there's also the Python documentation on their website's very useful, or you can also use help. And if you do, if you throw the data type, you can actually pull up the help documentation for that data type as well. And what this is showing is it's showing the class that defined that object. And if you're, it's a lot more technical, but if you don't feel like opening up in a browser to read documentation about Python, it's a very quick way to get down into like the code and see what's actually going on. It might be a little bit more intimidating for those who've never programmed before or have no idea what any of this really means. But this is, just think of this as like documentation and some pseudocode. Because like this is actually a generated documentation, so it's not actual code that's used to create that class, because like a lot of these lines here are just comments, and you would technically, to do a comment in Python, you'd have to pre-append the line with a pound sign. Yes?
So dir gives you the method?
It will give you a list of all methods available on an object.
Is that monkey patchable?
What do you mean?
Actually override methods on a class, like you can in Ruby?
Oh,
Monkey patching in Ruby world.
okay. For classes, you can recreate the types. I don't know if that's the correct terminology I'm looking for. But let's say, for example, you wanted to add functionality to an integer, to, let's say, do dot divide by 0. So you can handle division by 0 cases. You can inherit from that and create a new class, and then create that new class named as integer in your code. So that way you can call int, or when you create an integer, all new integers are created can still have those properties, essentially. So I can't really whip up an example of that right now, but if you want to talk afterwards, we can go over more about how to do it. But that's, since I'm trying to focus more on a little bit more beginner stuff, and that's a great concept, but it's a lot, it's pretty, I wouldn't say pretty, but it's kind of complex. But great question though, great question. But about the help documentation, you want to get quick help, don't want to open a browser, just use help and then the name of the object or the data type as well in the interpreter. And this works, in, like I said, if you're using a Python interpreter or IPython as well. So back to the dictionary list, we had info.states, but if we want to get the list of the keys, you can do .keys, and this will pull off the keys listed in that dictionary. And you can also do .values, and this will list the values as well. But so that way you can rip up the dictionary, essentially. And what's good about this is it makes it, well, I shouldn't say good, but this is a way to identify what's available off of a dictionary. Because when you do a loop over a dictionary, 4k in info.states, print k, when you put that temporary variable there, it's only looping over the keys. It's not looping over the key value pair. So if I wanted to print off, oops, for x in info.states, if I want to print off the associated ones, I do print x and then info.statesx. So what I'm doing is for each key in that dictionary, I'm printing that key, and also on the same line, I'm printing what that value is. And because I'm using the accessor call info.states, because with a dictionary, the accessor call is square brackets like a list. So we run this code, and we get the matchup there. So, but trying to do the reverse matchup, you'd have to do for key in info.states if, let's say, AK, and then for your equivalent, it's double equals info.states x print oops. All right, so what this did here is we looked through all the keys in info.states, and when we came to a value, because info.states, we accessed the value for the current key. When it eventually matched AK, we said we found Alaska. Yes?
Why in the previous one did they not come in the same order as what they were presented?
That's a good question. So in Python 2x, or any version of Python 2, dictionaries are non-sorted. So your keys are never stored in memory as sorted. So if you want to, for example, one of the common things to do with a dictionary is you want to get a list of sorted keys. And what you do with that is you use the .keys method and off that dictionary, and you throw that into a list, and then you run sort on that. And you can and with lists you can sort them very easily. So to do that, we'd say keys. Well, to prevent a variable glitch, we'll do KYS equals info.states.keys, and the print k will show it's out of order, but you can do sort, and it sorts in place. So now all your states are sorted. And now to generate the to access those in orders, you would just do 4x in KYS, and then you'd access the appropriate value with that, essentially. So it's in Python 2x, it's not very easy to handle sorted dictionaries, but supposedly in Python 3 they actually have sorted dictionaries. And speaking about the versions real quickly, most of your distributions are going to be run Python 2x unless you're using Arch Linux. And what I mean by distribution, I mean you're running Linux. If you run Windows, you can download Python from their website. As far as the 2 versus 3 paradigm, I could spend like 2 hours going on about which one's better, which one's worse. But the quick gist is, most of your legacy code's still in 2x, and a lot of your newer projects are still done in the 2x branch. There's still a shift to try to bring people up to the 3x stuff. Like I think that they're on like 3.4 now, or 3.3, or 3.2. I really don't use 3x because the two versions are not backwards compatible, so you can't really like take your Python 2 code and then just straight run in a Python 3 interpreter and vice versa. There are scripts out there that will convert your code for you, but those aren't 100% accurate as with your scripts that would convert your code from, let's say, Perl 5 to Perl 6, or from different versions in different languages, because, and I'd almost venture to say, once in a history of almost any language, there comes a time when they update the language to the point where they just kind of break it. So stuff's no longer backwards compatible. I'm not saying every language is like that, but it seems that's the general pattern for most power languages. There comes a version where some of your stuff just stops working, and when you try to run with a newer version of a compiler or version of Python, you'll find out that my stuff's not working, and you'll see a bunch of new errors and stuff, and you're like, I don't understand this, and it's just, a lot of times, just make sure you run the version number that your code was intended to run for. And you can also put in version checks in your software as well. So dictionaries, quick spiel about Python 2.3. Functions. To do a function, you just, your keyword you want is def, and then your function name. And then, oops, it's kind of hard to see. The variables you want to pass in, if you don't want to pass in anything, you just leave your curly brackets closed, and then you put what you want to do inside. And pass is a keyword that just says do nothing, and it essentially just passes. It does nothing. So now my func is still the function I can call, because it's a function that exists. It's just not doing anything because I didn't tell it to do anything. I just said sit there, essentially. And that's what the word pass is doing. It's just sitting there. So that's a quick way to create a function. You can return values with functions as well using the return statement. So you can do def my function, or we'll say multiply. I'll say return. Oops, should probably pass a variable in there. So we'll say import, or we're passing in two variables x and y, and we'll return x times y. There, if I can spell. All right, so now if I run multiply and I pass in 3 and 5, I'm getting out the multiplication of that, and that's what the return statement does. So it evaluates what statement I put in a return line, and then it shoves it back when I call it. So, and you can also store that into another variable. So I could do b equals that, and it will give me 15. So that's your very basic function. You can also nest functions within functions as well if you want to get really complicated. And like I say, you just got to make sure your indents are all handled well. And a quick thing about the indents, they're, depending on who you ask, depends on how you should indent. In your interpreter, it's usually when you hit tab, it's usually an actual tab character. The PEP8, which is a standard the standard written, that's like, it's more like a suggestion for most Python code, says that you shouldn't be using tab characters. It should be 4 spaces for every tab stop. So if you ever come across something that says my code's PEP8 compliant, that means there's a list of checks on how they write their code that it's valid by. For example, like the 3,5, that space has to be there to be PEP8 compliant. If you don't put the space there, it's still valid Python code, it's just not PEP8 compliant. PEP8 standard is very long. Very good read if you want to write your code in a very consistent manner and you want to stick to something like that. Very interesting though, there's also editor plugins that will validate your code for you. For example, I use VI, and I use a plugin called PEP8 or PyPEP8. That essentially I just press F5 and it does all checks for me, tells what lines are bad and then I just go ahead and fix them and then run it again, and it shows my code's valid. And I'll show you that on the birthday prom I was talking about. And then I already talked about our libs. We had, math and CMath, a few other powerful libraries that are very useful, especially if you want to do anything like any type of scripting. Is if you want to pull in stuff from the web, there's urllib2, and there's also random, and this would be useful for if you're trying to do the birthday problem as well. So you do the random dot, let's say rand int, and I want to generate a random integer between 0 and 100. I get out 12. You can also do random dot random, and it'll generate a random number from 0 to 1. And you can also do random dot seed, and what that does is it changes the seed of random to the current Unix time on your system if you're on Mac, Linux. And at the end here, I'll have a quick talk about Windows, about using Python Windows. I'll say that for the end there. Random generates random numbers. You can also pick random items from a list. So, and this is really useful if you're trying to like randomize some data. So we had, let's say random.choice, then we'll do info.states. We want counties. We want a list. Yeah, you have to give it a list, not a dictionary. That's why I got that error, because I tried passing it the info.states, which is a dictionary from the state name to the 2-digit code. So info.counties, you'd run this again, you'd just get a different county, and it just, so if you want to get a random from a list, quick way to do it. URLlib, if you want to pull in source code from a website, you can also do, let's say, source equals URL2, URL open. And 3 things here. URLlib2 is the name of the library, and you're calling the method URL open off that library. And you put in your link, and then the .read essentially takes the source code and puts into a giant string, and we're calling that string source. So it's just going to be one massive string. So if we do this and then print source, you're getting just one huge string. Probably not the most efficient way to see the code, but if you want to, let's say, parse order through it, you can do, let's say, source.split, and we'll split on new lines only. So we're not splitting spaces if we didn't provide a parameter. Now we create a list where each item in the list is now each line in the code. So if you pull up Google's code or Google's website and then did Control-U in your browser, you would get each item in that list is every new line. And there's 27 lines on your source code line, just pulled it in essentially. And that's what len does. It shows you, it's a global function that shows you a length of pretty much any data type you throw at it that has a method call on the class that allows for it. So if we want to do like, length of hello, it's a 5. You can also do that on a dictionary as well, and it would return the number of keys in the dictionary. So we do info.states, and we get 50. So we know we have 50 states. That's a quick way to verify how much you have of something there. So that's, those are a few simple things from standard library. There's also import OS and import sys, which brings in your different modules that are dependent on your operating system. So your .os, for example, would provide out information about the current operating system you're run Python. So if you run on Linux or Mac, the operating system calls the underlying C code Python's written in. Those will change, but the OS calls should remain constant. So that kind of allows you to write a lot more smoother code that's cross-platform compatible. And Python is cross-platform, so what you write on Linux should work on Mac and Windows, just like how Java is supposed to work on every architecture, without having to recompile essentially for, I believe. I forget the analogy with Java. I clearly don't use Java that much. I'm more of a C++ guy when I'm not using Python. So I'm kind of biased. That's why all my examples are leaning towards C++ there. So if you're a Java person, please forgive me. So your OS functions, you can pull in, like as you can see from this list here, the bottom half of the list, you can do your random. Actually, that's a function call. There. Well, you'd have to pass it. So if you want to see what it does, it's os.u random, and you pull it up, and it says you provide a string, return a string of random of n random bytes suitable for cryptographic use. If I can remember how to. Not sure why that doesn't work. But your OS allows you to access your operating functions, and your sys allows you to access your system accessible things that, for example, let's say if you want to pass command line arguments, you can do sys.argv, and that will provide a list of your command line arguments. It won't work in here because I'm inside the interpreter, because it's only going to show you what I ran, and I only ran the interpreter, so that's why it's only showing the first command line. If I was writing this inside a file, it would show me what I passed on that line. If you're doing command line arguments, you would not want to build a script that would parse that, because there's a bunch of libraries that already do that for you. For example, there's opparse, there's argparse, and lots of ways to do it. I believe argparse is the way to do it now, but I believe it requires Python 2.7 branch. But if you want to make your code backwards compatible, I believe you want to use optparse, OPT parse. And that goes back to 2.4, and then there's even something before that. So there's been lots of revisions to which library is recommended to be used for parsing command line arguments, because trust me, if you had to write a function to do it every single time, you'd grow insane pretty quickly, unless you really enjoyed that. So quick thing up to the birthday problem as I was talking about. As you can see up here, we import math, random, sys, and decimal, as I mentioned earlier. Doing some print statements, and we're pulling in some information from standard input using raw input, and the int function here is forcing that input to become an integer. So whatever someone enters, it forces into an integer. So when you type in 0, it's a string by default according to raw input, but we're forced into a type of integer. So if you type in, let's say, foo, it's going to error out because you can't convert foo to a number. To declare a few variables here, matches equals 0 and unmatched equals 0. And we have a function here where we have a function name called find matches, passes in numbers. And like I said before, this code is essentially simulating the birthday problem where we're generating a room of people with random birthdays. And we're generating, let's say, we're generating like 10 different rooms with the same number of people in each room, but every room has different birthdays for each people. And then we're analyzing if if we could find at least, how many people in that room share their birthday, essentially. So what the function find match is doing is it's looping over. It's looping over trying to find out if we have matching birthdays from the list numbers, because numbers comes in as a list, and we're saying for 4 number in numbers, and if numbers.count for each number is greater than 1, we're going to add that number to S, and S is a set we're creating where we're creating a set of the numbers that are matched, essentially. And then A and S is true, so that's the Boolean we create to say, hey, look, we found some matches. And then the trials is a while loop I put down here, so, because originally when I wrote this, I just did for, one classroom with 40 people, but I was like, well, that doesn't really show the birthday problem's consistent. So the comments show uniquely. So the comments start with these pound signs, and apparently in this terminal they show up as bold. I don't know how we can see that, but they kind of stick out. Depending on your editor, they'll show up differently. So we go through trials, and also you can do minus equal. I don't think I really mentioned that, but you can decrement as well. Minus equal 1. We seed the random. We reseeded the seed for random. You don't have to do this, but it creates more randomness essentially. And then the line here does, and I briefly mentioned it. And there's like a lot of things in here at once. But this is called list comprehension. And what that means is you can create lists from lists about lists. Now it's a loaded sentence, but if you're new to Python, it's very, 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 very powerful, I would say. Because it allows you to, let's say, let's import our info again. So let's say if we want to create a list of those counties, but let's say we want to change the capitalization on those counties in that list. So we can do x.lower for x in info.counties. Now what this is going to do, it creates a new list. That creates a new list where I applied the function or the method .lower off of the string x for each x in info.counties. So info.counties is a list of those counties. And we're doing our for loop from earlier where we're saying for each item in info counties. And then what's preceded by the for is what operation you want to do in that for loop. So it's a quick way to put a for loop on one line. But you have to do it inside the square brackets because you're generating a new list here. And it only works, this one line syntax only works as list comprehension. So essentially we create a new list from an existing list of lists. Or not of lists, but very powerful. You can do a lot more complicated stuff. It's pretty useful. Go back to our birthday problem here. Say then B-Day. All right, so we have our trials down here. Now down here where it's a little bit more mathematical. I'm not really going to go into the math too much, but the idea is with the birthday problem is they tell you, they have a formula to determine what the statistic is for having 2 people match on 2 birthdays in a room of X number of people. If you do a Wikipedia search, it'll show you the formula in a more pleasant way than code. Because I'm not really focusing too much on how the math works. It's statistics. I like observing statistics, but I'm not good at statistics. So it's really interesting. And one of the things that inspired me to write this script was I had a coworker of mine at the time who argued with me that the formula was BS. And at the time, I was sure if they were just mess with me or if they were serious, but they kept providing arguments against that. Statistics can actually show that with a room of 23 people, there's a 50-50 chance that you can have 2 people match on a birthday. So I created the script. I was like, well, look, we generate some random data and play with it. Let's see what actually happens. And never actually got a chance to show them it, but I thought it was pretty interesting because that way you're not just relying on that statistics. All right, so we'll run this throughout. And the round is a global function that essentially rounds a given number to a certain amount of decimals. So what we're doing is we're taking the number PE, which is a float. And a float, like I said earlier, is like 25.0, 25.7, or 3.14, and round to the 4th decimal. And it provides your standard rounding rules. If it's 0.50 or above, you round up, 0.49 below, you go down. So let's run this code. And I'll put this code's already available on my GitHub, actually. So if you want to actually pull up the code and mess with it, you can. The URL for that is github.com/Yano, and I believe it's birthday, probably. I don't know, just if you pull my profile /Yano on GitHub, you'll see it listed up there. So if you're on a laptop, you can pull that up as well. So let's run the B-Day code, and it's going to ask us, so it says, this will send the birthday problem by generating XX random numbers between 1 and 365 inclusively. So what we're doing is to represent each birthday, instead of doing the whole month, day, year thing, we're actually just generating a bunch of random numbers from 1 to 365. And if 2 of those match, we're saying that those are a birthday, because we're providing, because there's only 365 days in a year, most years, and by generating random numbers through that, we could treat each number as a different birthday, because essentially each birthday in a year could be represented as different numbers between 1 and 365. So the number of people, random people we want to generate, say we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 18 people in here. So we'll generate this, and we'll simulate, let's say, 25 rooms. The smaller number of rooms you have, this also calculates a percent of error. I threw in there as well. So so we did number of successful trials 7, and the percent of successful trials was 28. So that means 28 out of, okay, it's 20% of the trials were successful, and it was expecting a 34% rate of success. So that means out of the 18 rooms, 7 of them had at least 2 people with matching birthdays, and which is 28%. But according to the formula, it should have been 34% of the total number of people out of those rooms. And then down below, it tells you what your percent errors were kind of off. But the more number of rooms you simulate, the higher the closer it gets to. So now your percent error is -6, so it's a lot closer than percent of error of 24. And then the more people you have, the more stable it becomes. So let's say if we did 23 people and we did 100 trials, your expected percent of successful trials is about 50%. We actually, in this time we ran it, we got 57. And if we keep running this, the number of successful trials number will always change, and then your number of, but this number will stay constant because it's just a solid formula, and then percent error will change as well. But as far as like what Python's doing behind the scene here, there's a lot, it's mostly math operations that are calculating this out at the bottom. Oops. So down here, we're actually running through the formulas, and I had to do the result not equals 0 to prevent a division by 0 error, which technically if you do this simulation with 1 room, it comes up with a division by 0, I think. I'd have to double check my math. But more about the Python though is you can combine mathematical operations on one line. That's a big thing to take away from this bottom part. And you can also, as far as the math function, you can use, there's also math.factorials. So it's making a factorial of 365 exclamation point, because that's part of the formula. And 365 to the power of people plus math.factorial of 365 minus people times 100. So yeah, it's math. I'm not really going to too much explain about how the formula came out to be, but definitely really interesting if you're into statistics. And it shows you how it works with Python. If you want to, what's really nifty about this is if you want to make an argument about speed comparisons, you can also, on Unix, you can do time, B-Day, and then, So, quick thing to point out, when you try to run your files, make sure you're executable, even if you already have the shebang line in there. That's why then it works. So if we do, We'd also need to do that too. And then you could, store these numbers in here, but because I'm running time and entering numbers myself, it's not going to be consistent. But you can hard code those in there and then keep making mathematical changes to see if you could get speed optimizations. I keep doing that again. All right. Any questions so far? Anything about Python at all? I've covered most of everything. I'm going to go into how to access more help, how to access fancy stuff, really. For example, like I was talking about the Pi Google Voice thing, that's, if you do a Google search for Python and then what you're trying to accomplish, there's most likely an API out there that already exists, or you can build one yourself. As far as the standard library goes, let's say if you're making a URL call to Twitter, for example, and you're sending post data, like you can essentially tweet from Python like you can using curl on Linux. So you can essentially send a post or send your information, or even just search for information by passing a URL parameter to Twitter. Because if you ever look at Twitter's API, you provide what's an API code, the method you want to call, and you can pull up a list of a person's followers, for instance. And with that, you can take the source code of that, and if their API returns, let's say, a JSON object, there's libraries available that will help you parse JSON, so you don't have to build your own parser for that. And there's also libraries for parsing XML as well, so that way you don't have to manually use regexes. And speaking of regexes, it's kind of a little bit more advanced I want to go into, but you can do regex in Python, but it's not as nice as Perl, I'd have to say. That's one thing. Well, that's pretty much, in my opinion, the biggest strong point for Perl is its regular expressions, because really Perl's only, in my opinion, good for massive amounts of text processing. But with Python, regular expressions are a bit, it's an RE module, and you have to create an RE object, and you compile your regular expression here. So if I want to match on, let's say, A through Z plus, I'm not really going to go into what regular expressions is or the syntax for regular expressions, because that's a whole nother language to learn. But this is quickly, you create an object, and then to search something else, you do, let's say, hello world. So what this did is, I created a regular expressions object that searched on any lowercase letter from A to Z 0 or 1 or more times. I think it's 1 or more times with the plus. I forget regular expression for the plus and the star. And then the find all, you pass it a string, and then it returns every time it found that occurrence, essentially. So every time it found a lowercase letter A through Z and a plus sign, we got an output of list. So your output's always a list, and you can parse over that. Quick introduction to, I don't really want to spend too much time on this, because regular expressions, like I said, you could spend like a whole day on that, trying to learn regular expressions, but they are powerful. But the thing I was going with this was, as far as LXML, or XML and JSON, there's simple JSON. I don't know if I have it installed here. It's not in the standard library, but it's available through pip. And pip is probably your best friend ever if you're going to use Python. So on Debian, it's sudo apt install python-pip. And what pip does is it allows you to install stuff that's available to Python that's not in the standard library. So if we want to install simple JSON, we do sudo pip install simple JSON, and which box is this? Okay, and what this does is it goes to the pip server, downloads the file for simple JSON, and installs it. And it says it's installed successfully. So now if I try doing import simple JSON, it now works. I just installed that library. But the only disadvantage of pip is it has to be on the where pip's looking for it at. It has to be on the servers they're looking to ping. And I believe they run a central server. I haven't really looked into how pip works, but they host these files. So not everything that you can import into Python is available through pip. So like that Pi Google voice might not be available in pip. I would have to, well, we can search for it, but where I want to go with this is you can also, there's also LXML, Beautiful Soup, and Feed Parser. Those are your 3 options for parsing XML. I started on LXML. Well, actually, I originally started on regular expressions, trying to parse XML and regular expressions. Big warning for everyone, if you're going to parse XML or JSON, do not use regular expressions because you'll get a headache. And if you try to ask for help, everyone's just going to say, if you're doing it wrong, go use a proper library for this. Because the problem with using regular expressions to parse XML is that you can't rely on that because your XML might not return object states or all fields every single time. And your libraries can account for that and not throw crazy errors. Whereas if you're doing this with regular expressions, it would freak out. But Beautiful Soup was one thing I used next. It's more object oriented, so everything is like a method call. So when you import something to Beautiful Soup, all your fields are now dot methods off of that object. So if you really like object orientedness, Beautiful Soup might be for you. My new one I've been using is Feed Parser. It's a lot more styled for RSS readers, like if you want to build your own RSS reader, which I've done a couple times. Feed Parser handles that a little bit nicer in my opinion. Some quick sample code about that. Let's see if we can, yeah. Oh. So, quick backstory of this. I run an IRC bot called Jenny on Freenode, and I have a module called, well, it's NWS.Pi, and this is the National Weather Service Alert module I built. And this is where I got that states database from. And what this does is it goes to NOAA's, it goes to weather.gov, and like every 10 seconds it pulls down their massive XML file of all weather watches, warnings, alerts, and advisories across the entire country. And I parse through it and spit it out into different channels depending on which state you're in. So the quick way to show how feed parsers work in here, and I'm also using some database stuff, which I'll show as well, is, where's that? So, all right, so here's where I'm doing the parsing. So I have parse equals feedparser.parse and then warning _list. And warning _list is the source of the URL I pulled in, and I send it to feed parser, and with the .parse method, it goes through and looks at all the fields in there and then generates a data structure for that. And then from parsed, I can now access the entries field, and I can actually count how many of those I see. And if I have more than 0, I continue. And then, or if I don't have more than 0, I continue because that means I didn't find any new, or I didn't find anything at all. And then for entity and parse, that means for every time I see, or that's not entity, that's entries. Every time I see entries in parsed, I want to do this resulting code down here, and this is all run in an infinite loop, or an event loop, I should say, and it's handling that. And then there's a function called the top here that handles, or well, yeah. So parsing, yeah, okay. So entry equals entity. So now the entry dictionary, where I'm making all these calls where I'm doing entry, cap, certainty, and I'm assigning those to appropriate names. So essentially, entry is now a dictionary of the entire XML file I pulled down. Beautiful Soup, the difference when it does this for XML is you just do like entry.summary, and you'd have that object. So if you like the object orientedness of that better, that might be more for you. I like this a little bit better for what I was doing because there's I think like 30 different types available in there, and I didn't really need all those. I just needed, the important ones I thought for this data. So, I mean, you can make an argument of whether that's better or not, but in my opinion, the example code I found to do this on someone's blog was using feed parser, and I kind of just rolled with it ever since then. And now for everything I do with RSS, or XML files, I just use feed parser because I guess it's just what I've started using recently. Quick thing here, SQLite 3, if you want to create a database, you just do conn.connect. Not really, I didn't really want to get into this talk, but it's kind of, that's how simple it is to create a call to a database file, and then you do your fancy SQL statements if you know what SQL is. If not, don't worry about it because that's pretty advanced, more than what I really wanted to do with this talk. And then where is it? So that's how you handle XML, and you want to use a library for that because it can be very, very overwhelming, especially since some XML files are rather large. I believe that's most of everything, and I'm thinking I'm coming up on time too. Does anyone have any questions? Curious about anything, something I didn't cover that they wanted to see in Python? The talk was supposed to be more intermediate stuff like Python 102. I was kind of pressed for time because I was originally told prepare to talk for 2 hours, at least 2 hours, but at most 4 hours. And then, because I really didn't know how long this was supposed to last, and then with all the technical difficulties, it actually ended up being more like an hour and a half. Yes?
What's the base class that classes are derived from?
I believe it's called, yeah, just object. I believe, and don't quote me this, I'm not a Ruby person. I believe it's the same in Ruby as well. Yeah, so what he's pointing out for those who are not familiar with object-orientedness is that every object inherits from another object, essentially. And so what happens is there has to be a master parent, essentially, somewhere in the hierarchy or in the tree. And the master parent is where everyone's derived from. So think of it like, it's like Adam and Eve of all objects within your code, essentially. So everything's inherited from that. I kind of wanted to go into like how you create your own objects, but that was a little further past the time I really have available because I think it's supposed to wrap up in the next couple of minutes. And the execute code that you have created in a file, like I showed earlier, you just run Python, and this runs an error because I'm calling a thing that's outside directory. That's an error, nifty thing. So you can actually import directories in Python, which is kind of nifty. So let's say, for example, I want to import that modules folder I was just in. I can do that. And the reason I could do that is because inside that, oops, if I can get back there. So inside that modules folder, we have what's called a inet file that's blank. And if you put a blank $inet_.py file, it's telling Python, allow this directory to be imported. And then from there, you can actually call this file. So in Python, if we could do from, actually I'm already in modules, so we'll back up a directory. So we could do IPython from modules, import National Weather Service. And now I could call that file that's in that folder because I have the double inet file there. Because now, because by putting that file there, Python knows to now treat it as an object, essentially. You could use the import OS to actually pull out the source code of the file and try parsing it, but that's a lot more complicated, and this is a lot more easier. And then from .nws, you can do the functions I have in there, like alerts. And it shows you that's a variable I have of a string of where I'm pulling this information out on player.gov, for example. And then string formatting, didn't really go into that, but it's really powerful and it's different. If you get a chance, you can do a dot format on a string, but that's only available on 2.7. And I warn you right now because the 2.7 branch is trying to pull in stuff from 3 into 2 without making people go to 3 quite yet. So a lot of features are available in the 2.7 branch. Python will not work in Python 2.6 and below. Like the string dot format part will not work in Python 2.6 and below, or is it Python 2.5? I think it's Python 2.5 and below. They ported it to 2.6 and up. Also, you can technically do dictionary storing in Python 2.7.2, I think. But that, don't quote me on that. There's other little things in the 2.7 branch that they're really trying to bring over for Python 3. Some of it's worked, some of it hasn't entirely worked. But it's very powerful, and I believe the dot format was one thing they brought over. And what that is that when you normally do a string, say you do, so what this does is, oops, oh, I forgot to close my string. All right, so what that does is it fills in order this %s's. But if you're calling, let's say, like one string in several different spots in another string, you could use the placeholders and as whatever words you want with inside a string. And then when you do the dot format, your first one goes to 0, and then your second one goes to the 1. So you can do Mike, foo, Mike. And you only had to type Mike and foo once each. So the dot format's a lot nicer in the sense that you don't have to keep repeating the data. But if I tried doing it to %s, I'd have to type Mike a second time, because it's essentially saying you got to be very explicit in that. The dot format, a lot more general. Well, it's a lot more nicer on the eyes, and it's a lot more easier when typing the code out. And I think, is there anything coming up at 12:30? Anyone? No? Oh, I'll have my thing handy. It's lunchtime. I can keep talking if people are still interested. You want me to keep going? I mean, it doesn't really... I'll keep talking if people are willing to listen, really. But before everyone heads out, there's no questions at all? Or no questions? All right.
Is your Jenny going to be on the GitHub then?
The Jenny? Yeah. I actually... the fork that's... So I recently forked Jenny, and I made WXBot that's run on Freenode. So if you go to like #weather-us-ohio, you'll see me, Chanserve, and WXBot. But WXBot is run a more optimized version of the code, because one thing I found that was nifty, and this might become useful to you guys, but there's a library called TextWrap. And what TextWrap allows you to do is if you have a long string and you want to split on a certain amount of characters, but you don't want to break a word in half, it allows you to say, break on the nearest word before this number of characters. Because originally I was creating this fancy while loop, and I'm like trying to split on spaces and stuff and rebuild the string. And I was like, something I thought was simple ended up being like 10 to 12 lines of code. And I'm like, there's got to be a more Pythonic way. And this is another thing about finding help. There's #Python on Freenode. If you have any questions at all, feel free to ask them there. They're very helpful, unlike some other channels where they're... I'm not really going to get into that, but the idea is like it's a very warm community, and you can literally ask anything. They're not going to tell you the RTFM, really, so they're very friendly about that. But in all honesty, though, if you do have a question, Google first. Google's your answer first. You're more welcome to allow to contact me if you still want to learn anything else. Like I said, my GitHub is /myano, and you guys saw my domain name is yanovich.net when I was SHing in my box. If you guys have any questions at all, anything at all, pull my website, my email address is on there, my GitHub's on there, check out my code. And I use Python for almost everything. I think like 99% of all my projects on GitHub are Python, except for stuff I forked, like that I haven't really contributed to. Like, you know, you want to follow a project, so you fork it instead, and you're like, oh, I'm eventually going to contribute to this someday, but when I get around to it, and I have a lot of projects like that. Like my to-do list, like when I get around to it, but I'm sure if you're really into coding, you'll come across that. But general Python help, the Python docs are fantastic. The help function in Python, #Python on Freenode. There's lots of resources for help, lots of books, dive into Python. There's also How to Think Like a Computer Scientist Python version that teaches you Python and teaches you computer science at the same time. So it's very powerful, very useful. If you want, I'll talk to Eric, and might try to send out an email to the mailing list about like some resources for learning Python that I've routed off, because if you really want to listen, you don't feel like writing it down or somewhere, you're just going to find it on your own, whatever, that's fine. But just want to make sure you guys are aware there's the resources are out there if you want to expand your knowledge and keep going with Python, which I really encourage everyone to do with Python, because I originally picked it up, I think in '08 or '09 at Pi Ohio, and I've just rolled with it since. It's been my predominant language for writing everything. Like, in fact, it's actually kind of scary. Every time I try to solve a problem in another language, I start thinking natively in Python, like, why can't I just do like an accessor to get a substring out of a string instead of doing like the .subr thing in PHP and specifying my, yeah, so it's Python's awesome. Use it, love it, learn to appreciate it. Final words. Thank you. You can essentially create like your own server to, ping and check for information, do it back with your text messages. So Python's really powerful in that respect. A few things about the actual syntax. Python is dynamic and strong, which means that the dynamic means that you can't, the type checking isn't done until you actually run your code. Other languages like C++, the type checking is done when you run it through a compiler. And what I mean by types is you have like an integer, a boolean, strings, different types of variables. And then strong just means that you can't mix different types. So you can't add an integer to a string. You can't subtract a string from a list or an array, essentially. So you can't do it. So that's just a quick classification about Python. And then some common programming paradigms that are used in Python is what's called the Zen of Python. And if you run a Python interpreter, if you just do import this, it'll show a list of everything that, I believe it was Tim Peters. I believe was his name. It should be listed up here. Let's see here. All right. Well, I'm not going to try to fiddle with that. It essentially describes about like what's preferred in Python, around the philosophy of and what you should be doing with Python. One big thing, and it's kind of a disadvantage to some people who are coming from the Perl world, is that Python is that there's preferably only one way to do something, and it's usually obvious how to do it. Whereas in Python or Perl, it's Tim Toady, where there's more than one way to do it, and you can write one line of code in probably about an infinite number of ways, and they allow that powerfulness behind Perl. In Python, we try to make it vary an array of goofy characters. Okay, sorry about that. I did not know I had timeout. Sorry, I must apologize. This isn't not my laptop. It's the third laptop we had to go through to get a display on the projector. So I'm not entirely too familiar with this system, but as far as Python goes, Python's pretty much the same everywhere as long as you're using the same version, which that's another thing I should bring up real quickly, is that I'm using Python 2.6.6. On most Linux distributions, when you install Python, or when you install a distribution that comes with some type of Python, most of your distributions nowadays have some dependencies on Python. For example, if you run Fedora, Yum depends on Python. Actually, Yum was entirely written on Python. So if you're in Python, you can actually import Yum and call methods off of it, and you can actually essentially add new features to it, or you can fork the project and make your own package manager from it, which is pretty nifty. I actually wrote a script once that handled output from Yum, and it was very easy to do because Yum's Python. You just simply import Yum if you're on a Fedora system. Another advantage of Python has huge standard library, very powerful. You can, if there's something you'd like to do, there's most likely a standard library for it, or someone's created a project that they put on GitHub, Google Code somewhere, Gitarist, and you can just download it, and you can treat it as a library essentially. So there's a vast majority of things you can use. In fact, there's a Google Voice one where you can actually send text messages using Google Voice. You just need to store in, you're using a password. Well, it actually prompts for your password, but someone wrote the library. It's on Google Code. I think Google wrote it. I forget who officially authored it, but it's one nifty thing about Python is you just import Google Voice once you download it, and essentially just write text messages, check your voicemail, and you control file I've written, and show you the things I've explained and how it relates to how it's usable in the script itself. First, oops. All right. So, all right. First thing about the syntax or about the actual language itself is the different data types. I briefly touched on this. In Python, you have a few basic data types. You have what's called a list, you have a string, you have a dictionary, and you have an int, and you have a float, you have a Boolean, and you can actually find out the type of any variable or any information you have by just using the global function type. So if I create a string, let's say hello world, and then I want to know what the type is, I can just do type A, and it tells me it's a string, str, essentially. So that's an example of how, if you have an object, and you have no idea what type it is, and you want to know how to interface with it, you always do type. Another thing you do on an object, if you're not sure what it does, you can also do a global function called dir, and it will show you all available methods you can call out that class. Most people here, I'm hoping, are at least have heard of object-oriented programming. For people who aren't familiar with that, the idea is everything in the language is an object, essentially, and you can call methods off of it. You can you essentially call methods off of it. You can do different inheritance. You can build on different objects, and it makes it a lot easier because with object-orientedness, you can abstract your code and make it a lot more portable. So that way you're not having to essentially reinvent the wheel in several different spots. And that's why classes are so important, because you can actually create your own objects that represent complex data or complex systems, essentially. So like if you want, I'm assuming that's what everyone's here for, is learning Python. So this talk is Python 101, and we're going to be covering the basics of why you should be using Python, why Python's a great language to use, what makes it powerful, and how it can apply to several different applications. Not only like web applications, but also like personal projects if you need to write a script, to just parse through a file, to show you information off a website, or anything at all, really. Python's pretty powerful. It's also it's a higher level language like Ruby, and like C++ and Java. So it takes your code and it interprets it. It's an interpretive language. So if you've ever used a Linux computer or Mac computer, when you're using a terminal, you're using Bash, which is also an interpretive language as well. So when you type something in, your code's being executed immediately. You're not having to wait for it to save to a file, then throw it through a compiler, and then wait for the execute code to show some output or handle your data. So as soon as you type in code, it's valid. Or not valid, but it processes it immediately. One of the advantages of Python code that I'll be going over and I'll be showing as well is Python, and this is why I believe Python Python is a great language. It's very easy to read. It's very English-like. A lot of the syntax was designed to make the code very readable by other people. So if you're working on a project and you want someone else to come up to it, they can take a look at it, and they should be able to very easily understand what it is, because a lot of it will almost form English-like sentences. A lot of your comparisons can be done in using English operators instead of using weird symbol operators. Like if you're familiar with Perl, you have very fluid, try to make it more intuitive, more English-like, and more easy to adapt to different situations. So you can essentially write a code and pass off libraries essentially, and people could take that and use it. Since this is a tutorial talk, one of the tutorials I'm working on, I'm going to state the project name, so if anyone who wants to follow along could go ahead and start working on it. And I already have the code written up, and I'll show you the code I came up with it. But the idea is, is anyone here familiar with the birthday problem? Or the birthday paradox? I don't know if it's a paradox, but it's a statistic. I don't know if it's right here, but it's a statistical analysis that says that if you take a room full of X number of people, after you hit a certain number of people, you can define what the chance of two people sharing the same birthday. And I believe at 23 people, you have a 50-50 odds of two people in the room sharing the same birthday.
And let me interrupt just one quick second. Extension cords and power strips, in case if anyone needs them for their laptops, so they can continue to work. I'll just set them back here. You just put them wherever you want. Sorry about that.
Oh, no worries. All right. But the birthday prom, 23 people in a room should be a 50-50% odds that two people share the same birthday. The idea of the tutorial is that you build a script that simulates different rooms of people. You define how much people are in each room and how many rooms you want to test. And then you calculate out what the statistic should be and what the statistic actually is from random generated data, essentially. And you generate your own people and the birthdays. It's pretty nifty. If you love statistics, you might find it very interesting, but that's kind of the goal of the tutorial, is to walk through that and to create that. More so, it's going to be about learning a language, and then I'll deviate a little bit and pull up the